Hello, this is a walkthrough for Mastery Exam AA, Practice Version 1, Problem 8. And in this one, the very last problem on the exam, I'm asked to find all the solutions to x squared minus 20 equals negative 8x. Solving an equation again. So I know that I don't want to do this by guess and check, as we saw a little earlier when we were looking at, I'm going to refer back to this particular problem a lot here, that's x cubed minus x equals 0. Back when we had to solve this equation, we saw that guessing and checking can sometimes reveal a solution, but can often miss a lot of solutions too. So what I want to do instead is take this equation and work with it algebraically using correct algebra moves and see what I can come up with. So let's start by writing down the equation. X squared minus 20 equals negative 8x. So if I don't know how to solve this equation, I would like to go back and look at one that I had seen earlier that I did get a solution for, and that's this thing right here. Let's remember what happened, what worked for this equation here. When I was asked to solve this equation, I did it by factoring the left-hand side, and then seeing that I have a bunch of things multiplied together to give me 0. And so that leads to solutions of x equals 0, x equals 1, or x equals negative 1. The key concept in solving this equation, which we had seen earlier in the mastery exam, was that if I have an equation with a 0 on one side, I can then try to factor the other side, and that leads to my solutions. So let's see if I can do that here. I don't have a 0 on the right side of this equation here. It's a negative 8x, but I think I can do one simple move here to get a 0 on the other side of that equation. That's simply to add 8x to both sides. That's going to give me a new equation, x squared plus 8x minus 20 equals 0. So now this new equation, it's really the same as this equation, just looks different, is a lot more similar to the one I'd already solved, x cubed minus x equals 0. Because there's a 0 on this side. Let's see if I can factor this stuff over here on the left. And I think I can, because we've actually seen a problem earlier in this mastery exam where I had to do exactly that, completely factor a quadratic. So in this case, I can do that here. Let's set up my parentheses. This thing will factor into x, an x here and an x here. I need two numbers, probably whole numbers, that multiply together to give negative 20 and add together to give plus 8. I think I hunt around for that, and pretty quickly I come up with plus 10 and minus 2. I can check this with a FOIL method that actually works, so this is a correct factorization. So now I'm kind of in the same position again as I was right here. I could factor that left-hand side as I've done here. And then since I have two things multiplied together to equal 0, the only way that can happen is if one or the other itself is equal to 0. So I could have x equals 10 equals 0, or I could have x minus 2 equals 0. In the first case I get x equals negative 10, in the second case I get x equals 2. So I think those are my answers. I'm going to go put them up here in the blank, 10 and 2. Now, again, as always, when I have an equation, it's often very helpful to simply check and make sure the things that I think are answers really are correct. So let me go through and check. So let's take x equals 2, for instance. We'll only check one of these solutions. I would need to put x equals 2 in on the left side right here. I also need to put x equals 2 in on the right side and just compute those two sides independently and make sure that it works. Okay, so let's do that. On the left side, I get 2 squared minus 20. That's 4 minus 20, and that's a negative 16. On the right side, I get negative 8 times 2, and of course that's equal to negative 16. Now these two things here are equal, and that's exactly what I want. What that proves to me is that x equals 2 really is a solution. And you can do the same thing for negative 10 and come up with the same result. So those two numbers, 2 and negative 10, are solutions, and they are the only two solutions to this equation, because those are the only things that arose out of the algebra that we did correctly.